Hi, welcome to this webinar by Institute of Corrosion, Midlands branch. We are launching a series of webinars on the topic of AI in corrosion. It's a brand new topic, and there are a lot of activities going on across the globe. My name is Dr. Praful Sharma. I'm based in Midlands in the UK. I'm based in Cambridge, and I'm happy to host our speaker today, Mr. Kashif Salim, who's based in Middle East and representing company called Abyss Solutions, which is doing interesting work on AI-based corrosion inspections. So with that, without further ado, over to Kashif. Welcome, Kashif, and over to you for brief introductions and your slides.
Thank you very much, Dr. Praful. Really appreciate your intro, and thank you to ICORR and to yourself, Dr. Praful, for the opportunity to present the AI and corrosion world. How do we sort of bring these two together to create value for our clients? So today we will talk about AI-powered digital corrosion inspections and coating surveys and how we are changing the workflows and working along with the clients to add that value. I wanted to share a very relevant quote by Mr. Amin Nasser, the president and CEO of world's largest oil and gas operating company, Saudi Aramco. He was in a panel earlier in the year, January 2025, at the World Economic Forum, where he highlighted the corrosion impact worth about $3 trillion. That is the cost that is being incurred globally. Now that amount, now this was obviously a study carried out by the then AMPP or NACE back in 2016 called the Impact Study. But some of the insights there are, I mean, that number is like 3.4% of world's GDP. Let that, get that sink in. Now, implementing effective corrosion management practices and processes, leveraging technology, which we're going to be talking about today, can actually have a very positive impact on how we can reduce that cost and actually help the industry. Now, potentially that cost can be reduced by 15 to 35% by doing more to what is already being done by the industry. And that 15 to 35% can actually translate to maybe around 400 billion to about $900 billion. And that is very powerful. But what also, excited me from his quote was the fact that he called up on the SME, the subject matter experts, who understand AI and help create more opportunities in the corrosion industry. And now he spoke specifically about AI and corrosion, and I thought that was very relevant to what we are trying to do here in this session. And we will expand on that, on how AI and corrosion can actually help with that cost savings that we just spoke about. Now, before we dive into the actual technology, let's just look at how the industry is currently carrying out the inspections, what I call the traditional inspections. So we have these offshore and onshore assets that need some form of inspection and coating surveys. These are carried out by the API 510, 570 qualified personnel, very experienced, but they do go out in hazardous environment, rope access, and pretty dangerous stuff there. But there's certain issues around that. While this has been in practice for a while, these visual inspections can be costly, of course, depending on which region are you talking about. Middle East could be relatively cheaper compared to the North America or other Western regions. But this is more of a very manual process. It's subjective, and the coverage is usually is an issue. Now, if you look at a few examples on the top right, so I mean, in one case there is accessibility issue. So this item is inspected from the above the deck area, where it was missed out from the below. and there was significant corrosion out there. Similarly, we have subjectivity issues. I mean, two inspectors, if they come back with a report of the same asset, it's very likely they may come back with two different sets of reporting. In this case, it was identified as category 4, but in actually it was cat 2 or cat 1. Now, all that leads to is unnecessary painting or repair work that ultimately leads to sort of reactive maintenance. We don't want that as an industry. And what that does is it kind of increases the risk of unplanned shutdowns, loss of primary containments, and there's all these issues. And that's why we keep on hearing about plant shutdowns, unexpected shutdowns, and remediation, reactive maintenance regimes and all that. Now, today, the era that we are living in, we have got obviously a lot of industry advancements. We talk about AI and machine learning, and there are tons and tons of techniques that are being utilized for, let's say, using the computer vision, amalgamating it with the AI and machine learning to come up with the values, value for the client. And again, that's one of the solutions that we have developed for the industry. You have got, advancements in field robotics. We talk about autonomous perceptions. A typical example is the autonomous vehicles. But imagine you've got a field robot that is intelligent enough to take the decisions independently. We are no longer going to give that robot a specific track to go through and carry out, let's say, operator rounds. No, these things are changing very rapidly. So the robot is actually able to sense and understand its surrounding, the perception, and take the decision independently. And that is because of the advanced sensor system that we have, supported by the cloud computing. Now, all of these sensors, robots, they are generating terabytes of data. Now, in traditional or old days, we didn't have the infrastructure to actually, processing is a second stage, but even to store that kind of data was a challenge. But with the progress in cloud computing and cloud servers, its the scalability has been amazing. And last but not least, the subject matter expertise. I think that's very, very important. Given the sources of information and the databases that we have with years and years of experience, all of that combined together, that's what Abyss Solutions have kind of leveraged and developed what we call the Abyss Fabric portal, which is an intelligent portal that takes into all the data and then process it, and then we kind of visualize that with all the insights. Now, the Abyss Fabric works in sort of three distinct buckets, let's call them. So the data acquisition or acquire is the prerequisite, is the first step, and it's very, very important to actually get the right data, accurate data. I mean, that's the start. If your data is bad or it's not as per the required specifications, then we could have problems in the analysis part, or there could be some insufficient in analysis or insights for the client. So acquire, then we go to analyze. That's where we apply the proprietary algorithms and analytics, whereby we reduce the subjectivity and we can deliver, a significant change in the risk reduction. And we'll talk about that in a while. And then ultimately, we go to the insights generated from those analysis. Now, if we talk about the acquire, there are, multiple sources of sensors. In certain cases, we use off-the-shelf sensors or robots. Let's say we have got drones. That is something which are available. We work with a couple of partners globally. Then we have these TLS or terrestrial laser scanners that again are available off the shelf. So we have developed our system according to the data quality that we can get from these two. Now, then there are certain areas that you do not have, let's say, off-the-shelf hardware that you could just buy or rent out and then get the data. That's where Abyss, through our own in-house robotics teams, we have developed our own hardware. Let's say the autonomous water surface drone or underwater camera systems for integrating with the ROVs. So the idea there is to cover the asset from top to bottom, right? That's the ultimate result that we are after. Now, some example of these robots. So I spoke about the the autonomous surface vehicle, that is the Abyss Platypus, as we call it. It's a water-based platform. It's fitted with camera system, sonar, 360, laser technology, lidars, which kind of give you 180 degrees within the under the water area. And then for the surface, you will also be able to cover any anomalies. This was originally designed for long canals, aqueducts. We've carried out some port inspections. That's again just one acquisition device that is used to capture the data. And then all of that is kind of compiled together to then be processed in the Abyss Fabric platform. So that's the overall kind of concept. Gather the data from various sources and compile that into one single source of truth. So again, just an example of the terrestrial laser scanner. Now, this particular hardware is used for the offshore and onshore assets for the pressure equipment, including your piping and vessels and stuff. So the laser scanner is used to first we carry out the scan plan by looking at the asset itself, looking at the CAD files, the general measurement drawings. We'll go in, carry out the data capture, make sure that we manage to capture maximum area and coverage, because that's very important. Because the next step that's going to happen is we'll apply the corrosion analytics using the AI algorithm and the computer vision on the surface that you see here. So what the laser scanner does, it creates these hundreds and thousands or millions of points, what we call the point cloud on the surface. And that'll help create the digital twin, which is something that we can see the same asset in a virtual world. Now, the TLS is doing two things. It's getting the point cloud, which is what you see on the screen, the green points, but it's also taking 360 images, or the RGB images, as we call them. And then we are able to combine the two together to create like a true view of the facility. You could do virtual tours, you could walk around and see the asset from the inspector's perspective. Now, the same, the TLS, which is utilized for the inside of the asset, but you could have the need for the drone in applications where you wanted to get data capture for the externals. Some examples could be the flare stacks, for example, or other offshore assets where the TLS could be a challenge in terms of accessibility. You could also use the drone images for structural elements like the railings and all from the outside. So it has its own benefits and value can be added. So imagine data from TLS, data from drone combined together in Abyss Fabric, giving all the insights. That becomes very, very powerful for the client and for the insights. The analysis part. So once we've got the data, we are able to then apply the AI and the ML algorithms to kind of identify and classify the corrosion stage. So light, moderate, and heavy, for example. There are definitions. These can be customized. We are also able to use, let's say, some of the international standards like the ISO 4628-3, which is basically it's a method to assess the degree of rusting based on the density of the area. So all of these are built into the system. So imagine you've got the data, you've applied the AI algorithm to analyze that to international standards or to the specific client's internal standards. So there's some customization that can be done to the system, and then working with the client's workflows, make it ideal for them to kind of just integrate the digital system into their existing sort of processes. Now, obviously, with this type of outcome, there's always questions around the accuracies. So we have done some round robins, we have done some actual validations in the lab, site validations, and in terms of high-level results, we've got 97% accuracies on heavy corrosion, and that's important because heavy can lead to imminent problems. Heavy could have blister heights, for example, the corrosion scab. The larger the scab, the higher chances of wall loss. So we call these as alarm level 3, again, depending on how the clients or the operator defines it. There are multiple ways we can do that. But the blister height tool, it's something which is, let's say, patented in our case. And if you look at the right-hand image, that is what we would get from the blister height tool. Now, that is something which we used to carry out the topography analysis. Now, remember, we had the TLS data, which is laser point cloud. Now, that allows us to actually carry out the delta from the pipe surface to the corrosion scab and actually measure the height quantitatively. So you can actually, this is a sub-millimeter level accuracy. We can actually measure the height and then carry out the wall loss estimations based on an empirical formula. Again, in the industry, there's no fixed sort of standard for it, but it can, if you go very conservative, you could go to 1-on-1 ratio, which means 1 millimeter of a blister height will lead to a 1 millimeter of wall loss. That is conservative. We have obviously worked with clients who have got even 6:1. So 6 millimeter of blister height will give us a 1 millimeter of a wall loss. Now imagine if we could do that at scale for all the blisters, right? Now that is value for the client. For the mechanical integrity team, they can actually prioritize their work. And there's obviously so many values that we can talk about as part of the case studies that I've got for this session. Going back to the accuracy, so 97% for the heavy, which is very critical and important there. 95% for moderate corrosion is what we got, and just shy of 90, 89, 90 for light corrosion. Light corrosion is something which is what we call or define as coating breakdown. So it's kind of the coating has damaged and it has sort of started having some rust marks, something which can be readily remediated through, let's say, quick paint jobs. Now again, that is a value. If we can identify all the quick remedy areas, that is again a value for the client. So all of that is possible because of the digital nature of inspections. Now, in terms of the insights, right? So, of course, when you talk about insights, you've got management dashboards to work packs generation, to where is my anomaly or where are my hotspots, where is my prioritization list, and inspectors or the maintenance teams can go and attack the area that needs urgent attention. But imagine going down to measurements of surface area that is damaged versus clean, and within damage, what surface area requires quick painting and what requires spool replacement, for example. Now that kind of data is gold when it comes to planning your maintenance or even procurement of your paint material for that matter, because now you can actually pinpoint exact amount of paint that you require, exact amount of resources that you require to go out at site and paint. The insights will give you opportunity to plan before you go into to site. There's obviously a couple of other features, measurement tools and stuff like that. So that's the kind of insight that we'll be able to generate from that. Now, overall, if we look at the a glimpse of the actual tool, so this is one of the assets, for example, I'm sorry, that has been captured. And my apologies. I just have to play with this. So here you see a point cloud version of the asset that was scanned either through a TLS, a laser scanner, or a drone camera, right? And then what we can do, the analysis part will then allow us to actually segregate that. So we can actually cut it into various decks. We could do our analysis on deck level, on block level. So you could do some special arrangements there. And then you could apply basic filters, again, leveraging the AI, where in this case, we are applying the ISO standard for the RI values, which is your degree of rusting. And by just clicking a couple of links, let's say we're trying to look at RI 3, 4, and 5. So I can see as a bird's eye view, where are my hotspots? Where is my RF4, RF5 value? Right? At a click of a button at scale. Now I could do the same for, let's say, the corrosion analysis as well. Right now, I'm looking at the heavy, moderate, and light. Light being the coating damage, moderate being some sort of blistering or scab scaling, and heavy would be my corrosion scabs being developed, i.e. the the height of the corrosion. So if I look at all my heavy lines in this case, right, I am able to see from I think we had about 2,000 lines on this particular asset. Now, just by filtering all my heavies and alarm level 2 and 3, if you look at the left pane there, just by filtering these out, I'm able to come down to about 50 lines that are of interest to me as, let's say, an integrity manager or a maintenance manager. So I know that I need to plan my remediation, my maintenance on these specific lines. And remember, these lines are contextualized or they are tagged according to the client's PNIDs and their isometrics. So in a way, that process is also being digitized. So I can actually pull up individual tag number. I can pull up all my heavies on, say, 10-inch line, or I could pull up my alarm level 3s, which means if I don't do any remediation in the next sort of 8 to 12 months, this could likely go into failure or some form of a loss of containment. This kind of gives us that risk profiling on individual line on each component level, which again I think is very, very powerful. So again, we can pull in each line in the 3D isometrics world. The purple balls, by the way, are the scan locations where the scans would have been taken, making sure that we cover the sort of the whole asset on component level. And the corrosion mask is available on the 3D isometrics. Again, we can see that holistically and then go into a specific point. So again, clicking on one of the scan locations, I can see in my true viewer, how does that blister look like? And you can see based on my the corrosion analytics, I can see the red, the yellows, and the greens. The system will also allow us to put certain points of interest, or POI as we call them. So I can see all my blisters. I can search them. It's a database that I can always get into. Now, we saw earlier the blister height analysis tool. That is the measurement of surface and how that profile is being, or what is the footprint of the profile and what is the sort of the height of the profile. And that again is giving us the insights at scale. So we are able to generate that insight at scale for all the blisters. This is fully automated with the provision for manual intervention if required. So if, let's say, an inspector goes to site and he wants to validate something, he has found something differently, then there's always that opportunity to adjust the numbers. But the system is able to carry that out on autonomous basis. Similarly, we could do the same for the degree of rusting, which is something that is useful for the maintenance team and for the painting purposes. All right. So that's an overall overview of the system. Praful, how are we doing on time? Sorry, you probably are on mute. Let me just see. So okay, it's okay.
I think we are doing very well on time. I mean, if you want to show a few more slides, you're welcome. Otherwise, there are some question answers which are already coming.
Definitely, sure. Thank you for that.
I think we have 10 more minutes for your presentation, and then we can jump into question and answers.
Excellent. Yeah. So I think that nicely brings us to a couple of case studies that I got on the technology itself, because I mean, there are technologies available out there, but if you can't really get value out of it, it sometimes sits on the shelf and doesn't really add much to the operations, right? Now, in this case, because we're looking at the coatings management side of things as well. So with this client, we looked at they had severe corrosion issues. And Abyss Fabric's AI solution was applied there, and we looked at some of the insights. In this particular case, the assessment was carried out as per the ISO 4628-3 standard for the whole platform, and we looked at the paint-related issues. So what we found out based on their existing maintenance plans, that the Abyss Fabric tool, based on the digital insights and based on the AI algorithms, we were able to reduce paints for the low consequence lines by 60%, which means lesser paint material. I mean, lines that did not require painting were previously painted, but the insights from the exercise allowed them not to paint those areas. Instead, that resource base or that paint material was applied on high consequences lines, which were identified by the system. So straight away, that is risk reduction, or extending the life of the asset by not painting where it's not needed, but by more paint where it is actually needed. Similarly, we reduced about 18% in undeteriorated lines that were painted, and similarly 17% more damaged lines were painted. So, i.e., leading to a much bigger risk reduction for this particular asset. Similarly, another case where we helped this particular client, again in the Gulf of Mexico, de-risk their assets. Now, in this case, they had their standard or traditional inspection planned in about 2 years' time. And if we looked at their standard inspections in 2019, they basically covered about 20-25% of the platform, given the API inspectors. They covered about 500 lines through the manual inspections. They spent about 1.5. Again, this particular client based out of the Northern American region, and this was the cost that they incurred, and they had about 120 personnel on board days. This was the traditional inspections. The very next year, we introduced the Abyss Fabric tool for the first time. And the results were very clear. So we moved from 20% platform coverage to 95% in much lesser time. So we utilized only 20 personnel on board days. And that's the time that we require to actually mobilize to site, carry out the data capture, and demobilize. So you're talking about for a decent size platform or an onshore facility, you're talking about anywhere, say, a week to maybe 2 or even 3 weeks in certain cases that you need to be at site carrying out the data capture. Compare that with somebody who was there for the whole year doing 30, 28 days rotations month on month, right? So that's another major advantage with the digital system. We were able to cover more lines, and the cost incurred was way less than what they were previously incurring. This particular inspection was repeated again with the same data capture process. We obviously covered the same amount of area, same number of lines. The cost obviously reduced slightly because some of the processes were already done. For example, the tagging or the what we call the setup, one-time setup, or the deployment was done. So it was a quick sort of process for us. So all in all, the client saved a lot of resources. They covered more, and they actually de-risked their asset in a very shorter period of time. Lastly, again, another offshore operator, where in this case, their traditional inspection was due in about 2 years' time. Abyss Fabric was implemented. And what we found out that in Cat 3, which is your, let's say, the light corrosion, or let's call it the early paint remediation lines, we had identified 217 lines nominated for paints, lines that were not scheduled for inspection in the next 2 years. Now, so that would have meant that if they had waited for 2 years, they would have moved from Cat 3 to Cat 2, which would have meant that in year 0, they were supposed to just paint these 217 lines if Abyss did not give those insights. So instead of painting and costing them only $4 million, which they did incur, they would have paid $38 million if they had waited till that 2 years time period. So straight away, for this particular client, they had saved about 90% of their potential cost that they could have gone into. On the same platform or same asset, we looked at certain nominations in category 2, which, again, according to the estimations, the time to failure was anywhere from 8 to 12 months. And if they didn't do the inspections in the next year or two, these could have actually gone into potential loss of primary containment. And this is a significant, large asset. Now, 83 nominations were 83 components or lines were nominated for replacements. It cost them a certain amount, $14.5 million in this case. But what it did is it saved them from the risk, which could have gone into a significant number. In this case, some numbers provided by this particular client went into a whooping $1.2 billion tangible de-risking amount. So definitely the value is out there. Just need to work with the clients on how we can generate that value. Yeah. So I think the key takeaway, I mean, we can read through this, but I think for me the key takeaway is that we are in a very fast-paced era. And we, as all the attendees, I'm sure, are technical people, engineers, maybe some students, managers. We need to collaborate and share knowledge around AI, around our individual expertise that we all have here. It's, I think individual section of people, let's say whether they are AI engineers or robotics, they cannot do anything if there is no sort of working together with the other SMEs. There could be great products, but if there's no use case, there's no point. We as corrosion engineers will have better understanding of our problems, but if you don't have knowledge of AI, or if you're not coordinating with the robotics or AI engineers, again, we cannot have a solution that will be good for all. But I think, we need to work together to bring solutions that can help reduce the corrosion cost significantly. We saw the opportunity size is massive that Mr. Amin Nasser was speaking at the event there. But most importantly, I think at the end, I would just close with the fact that we need to develop solutions that are sustainable and have positive impact for our planet. And technology can help us with that. With that, I really appreciate everybody's time. Thank you very much. I hope we are pretty much on time there, Ruffle, and we're open for questions.
Thank you, Kashif. That was a very insightful presentation on the real use case of AI in the real world with some good tangible outcomes. I mean, some people believe that AI is a buzzword in many sectors, but when we see the real use cases with the real impact, that's where it's not a buzzword. It's actually real impact. So thanks for that. So let's jump into question answers. I will encourage all attendees. I can see a lot of participants, a lot of question answers already. So please post your questions. And we have Mr. Kashif's colleague, Mr. Hamza Alam, who is a subject matter expert, and he can also answer some of the questions in the question and answer panel. If you are not able to address live, probably we can have it written in the question and answer panel as well. So let's select some of them. Probably there are some 16 questions already. Let's see how many we can address. So let's jump in. So let me read through the question, Kashif, and if you are also able to see, we are seeing the first question here. Excellent presented. The question is from Mr. Stephen Tate. I can recognize the name, who's from ICORR president, past president. For the laser scanning, can that be applied to both insulated and non-insulated vessel?
That's a very good question. Well, we know it's applied to obviously non-insulated lines where a visual inspector can see that, and the laser scanner will pick everything on the surface. When it comes to the insulated lines, what we are able to do at this stage is that we can identify all the visual cues on the insulation itself, which means you're looking at all the missing plugs, seals, dents, vertical runs. There are like 19, 20 features that the system is looking at. But we are currently capping it at that. We're just saying, okay, let's identify. But the next thing in the roadmap is to then link that with the likes of the potential CUI problems. Now, I mean, and that will be a game changer, and that's where we will be working with technologies like, for example, corrosion radar, where there is a lot of synergies in terms of identifying the susceptible locations based on the external visual cues, and then that information leading to the susceptible locations, and then leading to potential installations of these sensors, right? So the simple answer is the laser scanner will not capture the under the insulation. It will capture the or the insulation surface, but the insulation surface will lead us to susceptible locations as we progress our R&D work that we have already engaged with.
Thanks, Kashif. I think another question from Mr. Stephen Tate is, in effect, you are quickly producing piping system isometrics, for which often no Oreo ISO previously existed in operator records. So how do you respond to that?
Yeah, so I mean, these are all the extra deliverables or feature or services that we call them, right? It's so it's not only isometrics, it's actually we could create full CAD model of the facility from our point cloud or laser data. So whether it's a full 3D CAD model, intelligent CAD model, primitive CAD model, isometrics for individual lines. And I think it's not only whether we can create or not, it's the speed at which these isometric drawings are created as well. Because we've got the digital data, it's a matter of a couple of software-based processes that we are able to then generate these isometrics. And then there is tons of other things. For example, the P&ID redlining, which is an industry-wide issue. It's a manual process. The inspectors or surveyors need to go to site, walk through the lines, and make sure they update the P&IDs. With this system, you could do that remotely at a fraction of a cost, at a fraction of a time. So there are multiple additional features that I have not obviously spoken about in this session, but yes, we could do that, even if there's no existing isometrics or CAD file available before.
Great, thanks. One question for Mr. Saurabh Sharma here. Is MIC, which is, I would say, microbially induced corrosion, can be detected in cold insulated pipings by scanning?
Yeah, Hamza, do you want to take that, or?
Yeah, I could take that. So typically, cold insulated piping is not something that we can directly scan using the sensor systems that we utilize for our corrosion detection. So what we do, however, have been able to demonstrate using the same technology is to understand the external ingress locations for moisture, which is, again, at the end of the day, associated with damage mechanisms such as MIC. So no, the laser system cannot penetrate the insulation to look at the condition of the pipe. However, we've been able to demonstrate correlation between the external condition of the jacket or the insulation jacketing with potential MIC and other types of CUI-related mechanisms. So I hope that clarifies.
Thanks, Hamza. That's a good answer. We have a question, Kashif, from Mr. Syed Mohammed. Is this visual assessment only?
It is visual assessment based on, well, for the external corrosion, yes. It is a digital, it's a digital version of, say, the visual inspections, with obviously leveraging technology, AI, and the computer vision.
Sure, thank you. Mr. Rakan Al-Shabel, he is asking a question. What key applications do you see for Abyss Fabric in Saudi Arabia beyond oil and gas? And what future advancements are planned and vision for the platform?
Absolutely, great question, Rakan. So we are extending the use cases to the likes of marine terminals in Saudi Arabia. There have been some discussions. We are also extending the discussions to the onshore section or sector of the oil and gas. And in terms of the future roadmap, it's actually very, very exciting. What we are seeing from some of the other operators globally, there is a significant push towards automating the maintenance scopes as well. So right now we are talking about inspections or automating the inspection workflows, but some of the global operators are now pushing us for for automating the maintenance programs as well. And I will just keep it at that, but it's exciting times, something that we will bring pretty soon to Saudi as well, because we need uniformity, we need minimal human exposure when it comes to these hazardous locations, offshore locations. So imagine if a robot could do. So imagine if Abyss system powered by Abyss, if we could do the identification, classification, and visualization through Abyss Fabric, but then that speaks to a robot who can then autonomously, based on the perceptive technology, go in and actually carry out the remediations. So that's in the pipeline, and we'll soon be coming out with more details.
Thank you. Another question from Mr. Sayed Mohammed is, can we do visual inspection of pitting in the equipment, like internal and TTS welds with AI?
So internal pitting, no, that is a limitation. This tool will only be applicable for external damages only. The only closest thing possible would be on the portal, on the platform, the data from your UT or ILI or any other NDT techniques could be integrated into the visualization tool that we have. So you could have both the worlds sort of integrated, and you could actually look at the data from one sort of single source of truth and have your planning or historical data all compiled in one location.
Thank you. We have a question from Professor Reza Javardasti. How do you define heavy, moderate, and light corrosion in your model based on what ranges of corrosion rates?
Yeah, I can give it a go. Hamza, do you wanna quickly maybe define that?
Yeah, I'll take that one. So this heavy, modern, light framework actually is more of a static assessment framework. So this is based on a combination of pit depth, scab corrosion, the presence of scab corrosion versus surface rust versus general coating breakdown. So typically, light corrosion would contain combination of general coating breakdown with some paint peel off. Moderate would have some surface rust formation and some initial indications of pitting damage. And heavy typically has some significant pit depth being detected by the system automatically, and then combining it with the visual contrast of the surface rust being at that level it lands it into the heavy category. So this is one type of framework. However, I'd like to point out that the system here is designed to actually pick up these base characteristics. So it is not actually picking up the light, modern, heavy per se, but it's actually looking at the depth of the pit, the contrast of the image, the coloration or the discoloration, the topography of the coating damage, and combines these factors to generate, based on a logic framework, light, modern, heavy. And that framework can be and is usually customized based on industry practices or specific use cases. So yeah, I hope that takes care of that point.
Okay, thank you, Hamza. We'll move to the next question. We are trying to cover as many questions as possible, and if we are not able to answer some of the questions because of limitation of the time, we'll get back by emails. So Mr. Shakil Ahmed is asking, does this technique give the exact thickness measurements?
No, we wouldn't call it measurements. This will be always an estimation, and that estimation is actually based on like that ratio that I kind of alluded to. So while the corrosion blister height is accurate to sub-millimeter level accuracy, we use that information to estimate the wall loss or the remaining thickness. Now that ratio changes from region to region, client to client. Now we have worked with some clients, let's say here in the Middle East, within certain corrosion handbooks developed by certain operators. They have got, let's say, 5:1, and we have worked with some other global operators who are using 2:1. So it really needs, so this is a layer where we work with the clients closely. We come up, we get some samples done, we understand the relationship, and then we apply an average figure, a bit on a conservative side, so that we can scale it up. So no, it won't be accurate, but it's a good estimation where this is then used for prioritizations. So while it's not absolute figure, it's used for prioritization. So you could actually say, okay, I'm reaching my threshold value, and beyond that, I need to do things differently, maybe spool replacement or whatever. But above, let's say, or less than 50% wall loss, I've got XYZ action. So it's it's not accurate. It's a relative way, or I would call it just estimated wall loss in short.
All right, thank you. Next question. Let's move on to Saurabh Sharma is asking how consequences were calculated by a model by seeing piping.
Sorry, could you repeat that, Praful?
How consequences were calculated by a model by seeing piping?
Consequences.
Yeah, how consequences are calculated.
Yeah, I could probably answer that one. So consequence of failure is typically something that we rely on the back end engineering data or the integration with an existing RBI system. So we basically do not determine consequence of failure for each item that is being inspected. We basically take that input from existing systems such as APM or Meridian or whatever the operators used to. So we basically have an integration pipeline that imports all consequence related information and associates it with the 3D model in our pipeline.
Okay, so Hamza, if I'm understood correctly, you are basically relying on RBI data provided by the operators on the consequence.
Correct. Yeah. So any RBI assessment or any type of damage assessment, we import it and align it with our assessment.
Got it. Okay, thanks. The next question is from Ricardo Terra. Considering Abyss FM and TLS capabilities, the hardware used to capture general 360-degree views is the same used to capture blister issues? Or do you have separate hardware for each use case?
Not for this use case. So the TLS, which, like I said, houses the laser scanner and the standard high resolution camera system. This is a single unit, and we haven't really come across a use case or application where we just need to, let's say, use either laser or the images. So for the blister height, we need the laser scanner, the point cloud, sorry, and it's all in one unit. So I'm not sure if I can answer the question, but it's not. We haven't really used a separate camera system when it comes to the pressure equipment. The camera only, we have used it in certain cases where we have utilized drones, for example, for again external imagery. But then that data is not used for blister height analysis.
Got it.
So blister, we need the point cloud, the laser point cloud.
There's an interesting question, follow on, slightly different here, which I'm also curious about. Is Mr. Ahmed Mahgoub is asking, there's no AI proposed solution for CP. I believe he's alluding to cathodic protection. And there's another person also, anonymous attendees, asking the same question. Can you incorporate cathodic protection into this model?
So I'll have a go at it. So no, however, the data from existing CP insights could be again integrated into the system. So again, but does that give a value? I'm not really sure. Hamza, I don't know if you can maybe add any perspective to this. Well, we haven't really looked at the CP, to be honest, in terms of a use case.
Yeah, not currently, no.
Okay. Yeah, fair enough. And I would say the next question is from Dr. Reza Jawardasti. It's a second question from him. Are you able to, A, distinguish among different types of corrosion to be expected on the asset, and B, predict corrosion severity in terms of expected corrosion rates on the asset, on the as-is asset?
Yeah, Hamza, is that something
Yep.
you want to take?
100%. So, for the first part of the question, essentially, yes, the system is designed to very clearly articulate between various forms of external corrosion. And I also saw a question on there regarding mechanical damage. So we've also built and trained models that are able to automatically detect, quantify, and classify certain types of mechanical damage, such as deformation or certain dimensions of cracks as well. So yes, any type of external corrosion, the system is able to detect the baseline characteristics and then use those to classify into various, not only severity levels, but different types of corrosion, such as surface rust, pitting, or paint scab formation. The other part is the interesting one, which is predicting the future state using the current state of damage, as I understand it, by incorporating some form of corrosion rate. So yes, this is something that we've actually very recently ended up doing by using multiple input scans from over a period of time. So if the same asset is scanned multiple times over a certain period, we've been able to overlay that data and form a trend analysis, which is basically your corrosion rate across that period of time. That is the most appropriate way to analyze corrosion rates using this laser type data. However, yes, if you have a static condition and you have some sort of a corrosion rate, we can also include that as part of our assessment and predict certain failure dates depending on the current state of damage. So yes, we're able to do both using any type of input data that we get.
Okay, thanks. There are sequence of some interesting questions by one attendee. Let me ask the first question. Do you envision this sort of digital inspection replacing human inspection? Or do you keep human inspection in the loop with decision support?
Yeah, I think it's the latter, or that's at least how we would like to see. Because if you ask my personal opinion, I think technology is here to enhance the human's capability, and we have to use it in such a way. It shouldn't be designed or used in a way where we are replacing humans, because there will always be that element of subject matter expertise. Now, in this case, what we are intending to do is to allow the inspector carry out more high value jobs than the mundane jobs. The system is able to do it for us at scale, at repeatable and reproducible, can give us the repeatable results and all that. So yeah, so our vision here is to enhance the inspector's capability, allow them tools, digital tools that can actually. You see, the ultimate goal in our discussion is to de-risk the asset and extend the lifespan of the asset and make sure there's no accidents or incidents or failures in these assets, right? And if we can do that by combining the two, I mean, technology and the humans, and if we can achieve that, that's what we are after.
Thank you. A follow-on question to that is, if the model is incorrect, who is liable?
If the model is incorrect, so okay, so there's been a lot of validations that obviously, I mean, none of the clients have actually gone in blindly and deployed it. There's always been a lot of pilots and proof of concepts technically, and there's been validations and all of that. So it's to say that if there's a third-party inspector, he gives a UT report, who is liable? As long as there is a sign-off from the operator themselves, they've obviously looked at all the results. So it's a similar thing. It's just that this is done by a system at a more at a higher scale. The underlying physics and the underlying mechanism is the same. So any operator who's looking at the results, the work packs, the reports, the maintenance teams, they are signing off on, and they would have validated that. So they're signing off on it, so the liability will still be with the operator.
Thank you. Follow-on question to that is, how difficult is it to convince the industry that AI works and is safe? And has there been any hesitancy from the clients? And what have you done to give them more confidence in the technology?
Now, very good question. So, yes, change is always a challenge, whether it's technology or otherwise. And we've always got to push through. It's not been an easy uh, journey, I would say. But what I can tell you from experience is once the clients or the operators, when they see the value, when they've gone through the initial phase of, say, trialing out the technology, because initially, there's very little belief in a system that can do, all of this, what was, let's say, presented a while ago. But when you actually get this done at an asset that they're breathing that asset day in day out, they're living on those sites, and when you show them what this can do, then it really changes the overall perception, and that's where the client then digs deeper into it. They work closely with you, and they want more. Now, I'll just mention that this particular product wasn't developed only by a couple of software guys or AI guys. It was a combination of a lot of our existing clients that we worked with. It started off with a very, very simple tool, but with all of their input. And again, the concept was same. Initially, there was hesitance, but when they started to see, how this is impacting their day-to-day work, how this is impacting the de-risking of their asset, they started to sort of intervene. They started to provide their subject matter expertise that we spoke of, and then it kind of evolved into something which is now bringing a lot of value. Now, when we go to new client who's not seen or done this before, we will have that challenge in the start. But once they start seeing the benefits, then they come in, they work closely with us, move the whole case along. They become our champions internally. So yeah, it's always a challenge in the start, but it kind of eases off towards the mid.
Can this scanner be used for high temperature or cryogenic piping? I believe, that's a question for TLS side of things. Also, can it also be utilized for hydrogen service equipment?
Yeah, so you see, as long as the camera is able to, there is a clear sight to the component or the asset. The temperature, we have not come across any issue. I think we have gone up to, I think about 300 degrees C, and we have done some cryogenics as well, some applications there. We have not really seen any issues. However, as long as it is insulated, the other limitation kicks in, right? Which is we cannot see the actual pipe, but we'll be looking at the visual cues of the cryogenic line or the insulation on top of it. There is obviously an optimum distance that we need to keep the laser scanner. It's usually between 3 to 5 meters to get optimum results. And as long as there's no permitting issues from the operator, we could capture the data from that particular asset.
Thank you. Mr. Kashif, with that, we have come to the conclusion of this webinar. There's so many more questions which are unanswered, so I would say we'll get back to them by emails. I will connect to you. I think it was a very insightful presentation. From ICORR Midlands, Institute of Corrosion Midlands branch in the UK, we are grateful for presence of Mr. Kashif and Mr. Hamza to share their expertise and the real use cases. For the attendees, thank you for attending this webinar. This is a series of AI in corrosion webinars. We are seeing real use cases in action, and this was one of the great use cases which we have seen today. I'm happy to see that AI is actually having an impact in the world of our industry, which is corrosion as well, in various ways. So with that, we conclude this webinar. Thank you for attending. So as I mentioned, as we mentioned in the announcement of this webinar, this is CPD qualified. So please email us if you need CPD certificate. We will issue you a certificate from ICORR Midlands. And sign in for future webinars. Please see our announcements on LinkedIn, ICORR Midlands. So please follow ICORR Midlands page. And to the attendees who could not, to the registered members who could not attend this, the webinar is recorded and it will be sent. Thank you for today and have a great day ahead.
Thank you very much, everyone, and thank you, ICORR Midlands and Dr. Praful, for having me. It's an honor. Thank you.
Thank you.
Bye-bye, everyone.